Module 7, Lesson 4, Migrating Virtual Machines. After this lesson, you should be able to verify vMotion requirements, perform a vMotion, perform a storage vMotion, and perform a shared nothing vSphere vMotion migration, and describe the major enhancements to vMotion in vSphere 6. Migrating virtual machines. Migrating a virtual machine is moving that virtual machine between hosts to another, from one host to another. We can move its data store, or we can move it to another vCenter system. We can do a cold migration. This is where the machine is completely powered down. We can take that to a new host or data store. Suspended, the machine's paused. We can migrate it to a new host or data store while it's suspended. We use vSphere vMotion. This will migrate a powered on virtual machine to a new host. Storage vMotion will move a powered on virtual machine to a new data store. Shared nothing vSphere vMotion is migrating a powered on virtual machine to a new host and new data store at the same time. This is a chart of our migration types. A cold migration, virtual machine is off. We can change both the host and the data store. We can do this across vCenter instances. We do not have to have shared storage, and different CPU families are allowed. Think about that, the machine's powered off, you're just picking it up, moving it. Suspended's a different story. It's still running in memory. Well, not really memory, but it's running to the virtual machine. It's still running. So we can move the host or data store or both. We can take it across vCenter service instances. We do not have to have shared storage. And when I say shared storage, it means that all ESXi hosts in the cluster are able to see the storage that the virtual machine's living on. Now this one, it must meet CPU compatibility requirements, because like I was saying earlier, it's suspended to the operating system. It thinks it's still running. So, imagine it would freak out because its instruction set is Intel, and let's say we moved it to an AMD system. It's not going to work because it's running to itself in memory using an Intel instruction set. So CPU compatibility must be met. A vMotion, the machine can be on. We can only change the host, so we can't move the data store. That's the next one. We can take it across vCenter instances. We do have to have shared storage, and it must meet CPU compatibility requirements, again, because it's running. Storage vMotion, we're moving just the data store. We cannot move it across vCenter server instances. We do not need shared storage, and CPU compatibility is not applicable for that. Shared nothing vSphere, we can move it while it's on. We can change both host and data store. We can go across server instances, and we do not have to have shared storage. And again, because the machine's running, it must meet CPU compatibility. Again, vMotion moves powered on virtual machines from one host to another. It provides overall hardware use and improves that because we can move hardware, do maintenance, replace hardware, and just move the machines over. It also gives you continuous VM operations while accommodating hardware downtime. And when you talk about DRS, it allows load balancing for the virtual machines across hosts. So here's the workflow. ESXi 1 and 2, this is ESXi 01. They have the same data store. It holds the virtual machines. And we want to vMotion it. So what happens, it takes a memory bitmap, copies that memory over, creates a virtual machine over here, and then rides over to vMotion network copying that data, which is, again, it's a good idea to separate these from your production network. That way operation still goes on and we just have our own network for vMotion, and it copies that over or moves it actually. So when it's done, the virtual machine's actually living over here. You're just doing the memory because they share the same data store. So no storage gets moved, just the memory, because that virtual machine's running, and it moves the lock over that says, okay, now you've got access to this shared storage. So, here's what he's doing. Here's the lock to that file. To do a vMotion migration, the VM should not have an active connection to an internal virtual switch, because migrating the switch will produce an error. The VM must not have any kind of CPU affinity configured, and the VM cannot have a connection to a virtual device, so you can't have like a connection to a CD-ROM or a floppy that's local to that ESXi host. Another thing to note too, if you've moved your swap file for the VM to another location, if it's not acceptable, then vMotion must be able to create a swap file that's accessible on the destination host before the migration can run. And if a VM uses an RDM, the RDM and the LUN to which it maps must be accessible on the destination host. Host requirements for vMotion. Accessibility to all the storage that's used by the virtual machine. You can have 128 concurrent vMotion migrations per VMFS or NFS data store. You need at least 1 gigabit Ethernet network. Each vMotion process requires a minimum of 250 megabits per second. So you can have 4 concurrent vMotions on a 1 gig network. You can have up to 8 on a 10 gigabit or faster network. You need to have compatible CPUs. You can, if it's a newer processor, you can use enhanced vMotion compatibility to find a common ground for all your processors. But they still can't be mixed of Intel and AMD. That have to be all Intel or all AMD. CPU constraints. Exact match on clock speeds doesn't matter, because that's virtualized away by the VM kernel. They do have to be of the same manufacturer, the same family, because the instruction sets are different. The presence or absence of SSE3, SSSE3, and 4.1 instructions. You do know that because it's multimedia instructions that's usable by applications. The hardware assist, it doesn't matter for 32-bit VMs. For 64 on Intel, it does matter. And that's because on the 32 it's virtualized away by the VM kernel. But when you're the hardware assist, the 64-bit Intel VT, it's passing that through to the VM, so the hypervisor is not masking it in any way. That's why you'd have to have they have to be the same. Other things you can do in the EVC for vSphere vMotion. This is what it does, and it tells you here you can pick your EVC mode, and it'll tell you what's compatible with it. EVC is at the cluster level. It uses CPU baselines to configure your processors in that cluster. EVC requirements, again, as I've said a couple times in this slide, is or these slides, they need to come from the same vendor, either all AMD in the cluster or all Intel. They need to have AMD V or Intel VT enabled in the BIOS on the host. They need to be enabled for execution disable, which is AMD no execute or Intel execute disable. And they need to be configured for vMotion migration. And applications in VMs must be CPU ID compatible. You can identify CPU characteristics with the CPU identification utility, and it's an ISO you can hook to a VM and boot up, and it'll show you this screen when it boots up, telling you information about your CPUs. You can check vSphere errors when you go through the wizard on migrating. In this example, Mike 203, it's got a DVD drive in use, and it's telling you where it's at. So we need to go put it back on client, or where it's not using that ISO file. Evidently, this will be okay if it's on the local storage. If you notice, if it was on a shared data store, you wouldn't have a problem. If the destination could see the data store, in this case, just by looking at it, I know it can't because it says local ESXi2, which is why it's giving that error. vStorage uses I/O mirroring to copy the disk blocks between source and destination. It initiates the storage migration, and then the VM kernel uses a data mover or the vStorage APIs to copy the data. And it starts a new virtual machine process. The mirror I/O calls the file blocks that are already copied to the virtual disk on the destination, and then the cutover to the destination starts accessing the virtual disk copy. Coolest thing, storage vMotion is pretty awesome. You think about, you have a big array and you're wanting to change to a new array. And I've done a lot of migrations like this. You just stand up the new array, shoot your LUNs out, it'll create data stores, just right click on VMs and do storage vMotion. I mean, it could take some time, but the thing, I tend to do them so I don't overwhelm the system, like one or two at a time. And it's just really awesome because all of my virtual machines will get over to the new array and they don't have to redo anything. Like I said, it can be time consuming depending on the size and how many VMs you have, but it's really nice because you can do it while they're running. You don't have to have any downtime for that. vStorage vMotion guidelines. Plan the migration, coordinate with administrators, perform migrations during off-peak hours, which is something I was just saying. I wouldn't do it during a big production run. Kind of schedule around that. Ensure that the host has access to the source and destination data stores. Limitation, independent VM disk must be in persistent mode. Shared nothing vMotion. It will take a VM storage and host to another one in one single operation. You can do this between hosts, within hosts, across data centers, send it to another vCenter server. Multiple changes can occur simultaneously with shared nothing vMotion. Again, like I said, we can change, go between vCenters, we can go across data stores, we can go across networks. We can migrate virtual machines between linked vCenter server instances. It has to use, they must be in enhanced link mode. The time needs to be synchronized. And it doesn't say it's have to be, but I would want them to be, they need to be the same vCenter version. VM kernel networking layer and TCP/IP stacks. The VM kernel, it provides your IP storage, fault tolerance, vSAN, and any kind of network operations needs a VM kernel. You can also create VM kernels adapters on the source and target vSphere replication host. This will help isolate replication traffic. And one thing to remember, anytime you create a VM kernel, you can give it an IP address. In vSphere 6, each host has a second IP stack dedicated to vMotion migration. And that is correct because, and you'll create it as a, when you create your VM kernel, you can have a checkbox to tell it this is vMotion. Long distance vMotion. This is an extension of vMotion to migrate across vCenter server instances. And it could be where you have a lot of latency, not as much bandwidth. Use cases would be permanent migrations, disaster avoidance. Maybe, hey, we're having a hurricane hitting us on the East Coast. Let's migrate. Just go ahead and just move this straight over to our West Coast data center. We can use Site Recovery Manager to avoid that as well. We can have multi-site load balancing, and we can use the follow the sun scenario support. To do long distance vMotion, they must connect over layer 3. The VM virtual machine network needs to be an L2 connection. They can be the same IP address. The round trip between the hosts can be up to 150 milliseconds. Now on a vMotion network, it needs to be a layer 3 connection. It needs to be secure. This is recommended if you're not doing vSphere 6.5 encrypted vMotion, and you need to be able to do 250 megabits per second per vMotion operation. vCenter performs network compatibility checks to prevent configuration problems. It checks the MAC address compatibility on the destination. It migrates from a distributed or to a standard switch. It migrates between different distributed switches of different versions. And it migrates to an internal network, like you could take it to a virtual switch that doesn't have an uplink or a physical NIC. vMotion always uses encryption when it's migrating virtual machines. You can pick whether you want it to be disabled for no encryption, opportunistic, which means it's used if the source and destination supports it, and required means that it has to do the encryption at the source and destination, or it's not going to vMotion it. You should now be able to verify vMotion requirements, perform a vMotion migration, perform a storage vMotion migration, perform a shared nothing vMotion migration, and describe the major enhancements to vSphere vMotion and vSphere 6.